Yeah, all right. Um, since I believe free speech is still allowed, let me just say that the IB data pack is just a mess. Okay, the organizational scheme is faulty. I would have laid it out just like this. Okay, so here are basically the same formulas you just saw, but this is they are organized by a sane person and not a mad person. Okay, so this is our force of gravity. This is our for electric force, right? Okay, this is the force between two masses, a distance r apart. This is the force between two charges, right? A distance r apart, right? So here's just mass one, mass two. Here's Q1, Q2, right? Okay. This is the field, right? That's the gravitational field. Here's the electric field. Remember, field is subjunctive, right? It's the force um, per unit mass, right? Is what this is, right? So this is guys going to be newtons per kilogram. This is going to be newtons per coulomb. Also, by the way, you can say volts per meter. Maybe I'll remember to explain why that's the same thing, right? This is more common, by the way. All right, and then here is the formula for gravity, right? And they basically they have it in the packet like this, right? G big M over R squared. This guy is not in the data packet. Wasn't in the previous ones. Not in this one. They don't love you. Okay, but just remember, you're smart. You can see this formula. You know the other one's got to be this, right? Instead of M, it's Q. Instead of G, it's K, right? Same exact thing, right? Now let's go look at the energy ones, right? They used to have these in the old data packet. Now you've got these. Okay, this really means energy. So that's good. But this is common. This is you'll see that in college. Work and energy. Remember, work and energy. Work is a transfer of energy. Okay, and so this is the work needed to move the mass. That's the change in the gravitational potential. Remember, that is now joules per kilogram. That's what VG is in. Right. This is going to be joules per coulomb, right? That's what the voltage, right, or the electrical potential, right? And you can use electrical potential and voltage are synonymous, right? So you can use it to avoid redundancy, right? Can you measure the electrical potential in volts, right? It sounds better than can you measure the voltage in volts, right? Okay, just don't call current amperage. Promise me that. Okay. All right. So this is our electrical potential, right? Or the V that doesn't need a subscript, right? Okay. So there those guys are, right? Um, and then if we look at these guys, right? These are the more of these things, right? Notice that gravitational potentials, there's a symmetry here, but because just like me, gravity is always attractive. I used to get a laugh from that. Okay. Because gravity is always attractive, it's always a negative potential, right? It's like the sheet of rubber. Gravity always pushes the sheet of rubber down. Right? You got the sheet of rubber, it always pushes it down. Doesn't There's no anti-gravity. Nothing pushes the sheet of rubber up. Whereas positive charges, if this is the sheet of rubber, right? Positive charges push it up. Right? Negative charges push the sheet of rubber down. Okay. But these guys are always negative, right? Now, this minus is just because that's the way gradients work. Okay, if I have a slope, the force is going to be down that slope, and that's why there's a minus sign there. Okay, this is a gradient. This is the potential gradient, right? This is gravitational potential gradient, right? This is the electric potential gradient, and the gradient is always down that slope. Okay, so by the way, away from positive charges, you can see it would be away from that toward negative charges, right? Electric fields are away from positive toward negative, okay? That's what we mean, right? Because this slope really is positive on there, but the force or the field would be away from that, okay? Um, yeah, so here's that guy, right? Okay, and then here are the potential ones again, because gravity is attractive, right? This is a minus sign. Um, Here, the default is that we have two positive charges, and that would be a positive amount of potential energy. Yeah. Anyway, this is how I would have organized the data packet, and not the way they did, apparently.